Here in this lesson, that will be lesson number 1 related to CSS GSA 2020 preparation. I am going to discuss a topic from statistical diagram, and the topic will be scatter diagrams. We have different types of diagrams as well as representation of data is concerned. We have pie charts, bar charts, histogram, pictogram, scatter diagram. So I am going to discuss scatter diagram today. A scatter diagram is used to find out whether there is a correlation or there is a relationship between two sets of data. So the question arises that whether there is a correlation or relationship. Yes, we have basically sometime there may be a correlation between two sets of data, sometime there may not be a correlation between two sets of data. Now I will be explaining this point using the diagram. How a scatter diagram look like? Now this is a scatter diagram, and this one is for marks of maths and physics. Okay, on y-axis we have got marks for physics in various tests, and on x-axis we have got marks for maths in different tests. Basically, you are going to plot them on the graph or on the chart like this. Okay, let me explain using the data. These were the marks for maths, 150, 152 suppose out of 200, then 155, and here you have got marks for physics, 56, 62, 63. So when you have got 150 marks in maths, you have got 56 marks in physics, and you can see that this point is plotted on the diagram here, this one. If you can see, you have got 150 marks as from this table, 150 marks in maths, and against 150 we have got 56 marks in physics. Now you are going to plot them on a graph. 56 marks, okay, here you have got 56. Now 56 marks in physics, y-axis is for physics, and 150 for math. Similarly, you can plot the next point. Now this point is when you have got 152 marks in maths, this one x-axis is for maths, and when you have 152 in maths, you have got 62 in physics from this table. 152 in maths and 62 in physics. Suppose this was test number 2. In test number 3, you got 55 in maths, and in test number 3 you got 63 in physics. Go to your graph. Now this point is showing that here marks for maths which are represented on x-axis is basically they are 155, and marks for physics which are on the y-axis, no, they are 63. This point is plotted in this way. Similarly, you can plot this point where marks for maths are 158, that will be on the x-axis, and marks for physics are 64, no, that is on the y-axis. This is a simple graph plotting like you do in other graphs. In this way you can plot all these points using your data. This is your data: marks in maths, marks in physics. Marks in maths are on the x-axis, this one, while marks in physics are on the y-axis, this one. So you have plotted all your points. Now these points are scattered. Now this is a scatter diagram. Now this scatter diagram represents a relationship. Yes, points are scattered, but they are not scattered a lot. You can draw the line of best fit in order to explain your correlation. Now first of all, because points are a little bit scattered, mean they are not exactly on the same line. So let's draw a line of best fit. Now let me explain what is the meaning of line of best fit. Line of best fit means a line around which you have equal points, almost equal points. Okay, suppose this line, if I consider this one as the line of best fit, then if you observe, we have got almost 3 points above the line and 4 points below the line, while 2 points are on the line. So this is the line for best fit, because you have almost equal points above the line and you have almost equal number of points below the line, while 2 points are on the line. Now from this line, what type of relationship can be deduced? Now this is a positive correlation. Positive correlation mean when marks of physics are increasing, marks of maths are also increasing. Suppose at this point on the line, here you have got how many marks for maths or how many marks for physics. Here at this point you have got almost 7. Okay, you should restrict your conclusion within the range of your data. Now the point is that when you have to take out some value other than these values that are given, you must be in the range of your given data. So suppose at this point I have to be in the range within the maximum point and within the minimum point I can evaluate my value. No, here at this point the marks for maths are almost 172.5. Here you can see 172.5, and against these marks you have got marks for physics that are equal to 70. Now here you can find unknown values. If I ask you to tell me the marks for physics when maths marks are 167.5, now this is 167.5. you can go vertically to touch the line of the best fit, and then you can move horizontally to find the marks in physics which are 67.5. in this way you can find out any missing value. If you know the value of maths marks, you can find out the value for the physics marks. Moreover, this is a positive correlation, mean if the marks in maths are increasing, suppose 165, if you have 165 in maths, then you have 66 in physics. And if you have 170 in maths, the marks are increased from 165 to 70, then marks in physics are also increasing from 61 to 68. So if marks in maths are increasing, the marks in physics are also increasing. Now that is a positive correlation. This is how you can explain a correlation between two sets of data, and this is a positive correlation. So this is one part of scatter diagram. In my next lesson I will be explaining negative correlation and then no correlation between two sets of data. Thank you so much.